Hello, everyone. Welcome to the stream. I'm glad that you're all here. I am Peter, and what we're going to be doing today is we're going to be working on our JupyterHub deployment. But this JupyterHub deployment that we're going to do in this episode is complete with Ansible automation. So if that sounds like something awesome, stay tuned. So I'm Peter, and I teach engineering during the day, but I'm also a blogger, and I blog about computer programming. So you can see my blog here, Python for Undergraduate Engineers. I'm also an author, and I wrote this book, Problem Solving with Python 3.7 edition, a beginner's guide to Python and open source programming tools. If you like this stream and you'd like to support my work, you can pick this book up on Amazon. We've been working in this series on a JupyterHub deployment. Here are the JupyterHub docs, the documentation for JupyterHub. And if you'd like to know more about JupyterHub, what it is, you can go to this set of documentation. If this is the first stream that you're listening to, JupyterHub is a way to write and run code in the cloud as opposed to writing and running that code on your local computer. JupyterHub is often used to run Python code, but other types of code can be run with JupyterHub as well. And JupyterHub runs that code in Jupyter notebooks. The documentation that we've been following so far in this deployment can be found here. But the stuff that we're going to be doing today, that stuff isn't here in the docs. It's kind of like more experimental. I'm kind of doing it now for the first time. So what you want to do if you want to see this code is to be able to go to the GitHub repo for the stream. So here is the GitHub repo for this stream, and we are in Season 1, Episode 8. So we're going to be doing Ansible automation. We're going to use Ansible Playbooks in order to deploy JupyterHub using all the steps that we've done so far in the last 7 episodes. But we're going to automate it and kind of do it all at once. Pretty cool. So in order to do this, I'm going to do this on a DigitalOcean virtual private server. We did the previous deployment on Linode, but I'm going to do this deployment on DigitalOcean. So if I open up DigitalOcean.com, you can sign up for an account. And if you go to a lot of places, you could look for a promo code for DigitalOcean and get some free credits. So once you're signed up for an account, you just click here on the sign in link, and then that will bring you into your DigitalOcean profile. So here I've got a project, and this is an ENGR114 JupyterHub project. And in this project, I've got this one domain name. You can add domain names to DigitalOcean, and those domain names can be purchased from other places. So this is a domain name that I got on Google Domains and then added it to DigitalOcean. And you just want to include ns1.digitalocean.com, ns2.digitalocean.com, and ns3.digitalocean.com for the name servers that you send your domain to if you're using JupyterHub for your deployment. So I'll show you all that in a sec, but we want to create our server early on in this stream and then link our domain name to it very early on in the stream. And that's because we need to wait for the DNS record to propagate. So here in this project, I'm going to click Create New Droplet. Droplet is DigitalOcean's word for virtual private servers. And we're going to select the newest version of Ubuntu, which is 20.04, the new long-term release. And I didn't know this, but the 20, that's the year, and then 04, that is for April. So this was released in April, but it's going to be supported for a long time. We can stay with the standard starter plan. I'm going to click this left arrow here and choose a $5 per month server. We won't add any block storage, and I'll choose a data region close to me. I'm in the Pacific Northwest, so this is close. I don't need a virtual private network, so we can skip that option. And here for SSH keys, if you don't have your SSH key loaded on DigitalOcean, then you want to click this new SSH key button and then paste it in. Mine are already saved here on DigitalOcean since I've used it before, so I'm going to click here for select all. So next, we're going to choose how many droplets we want. We'll just use one, and then we'll give it a host name. So let's call this one Ansible JupyterHub. Any tags, you could add them here. Since I've just got this one server, I'm not going to put any tags. In this current project, that's good. And then we'll click Create Droplet. So it'll take a couple minutes for that droplet to be created and for our Ubuntu software image to upload on it. And it's done. And what we want to do is copy the IP address here. So our server is up and running. So next what I'm going to do is I'm going to link the domain name to this droplet. So I'll click on the domain, and then I'll use the @ symbol, and then we'll redirect to that droplet that we just created. And then here we click Create Record. So this creates a DNS record that should route this domain name to our DigitalOcean server. Alright, so let's just quick take a look at what this looks like on the domain name side. So I got my domain from Google Domains. So I'll type in Google Domains here in the search bar. And then if we go to domains.google.com, and I can take a look at my domains. If I look at this engr114.org domain, I just want to show where the name servers are routed to. So if I click Manage, and then this DNS menu option here, and then you want to do Use Custom Name Servers, and then ns1 DigitalOcean.com, ns2 DigitalOcean.com, ns3 DigitalOcean.com, and then you want to make sure that you click Save after that. So I've done this previously because I wanted to make sure that this was up and ready for the stream. Then once you got that hooked up, in DigitalOcean, you can click this Create, and then domains DNS, and then you can enter your new domain, and then you can choose which project you want it to go to. And I've already entered this domain. It takes a little bit of time for the DNS records to populate, so that's why I did this before the stream started. Okay, so while that is going, let's open up a terminal. So here I've got my terminal open, and I'm going to cd into the Documents folder, and then cd into my Stream 2020 folder, and then pull the most recent version from GitHub. And now I'm going to type code dot to open up Visual Studio Code. Now if you notice something different this week, I am coding here on an Ubuntu operating system, not on a regular Windows operating system. And the reason that I'm doing that is that Ansible does not work on Windows. You can't run Ansible on Windows. You can run it on Windows Subsystem for Linux, and you can run it on Mac OS, but you can't run it on Windows. And running it on Windows Subsystem for Linux, plus running OBS, plus having VS Code web browser open, all that was too much for my little laptop. So I'm using a desktop that has Ubuntu installed on it, and Ansible can run on this just fine. Okay, so we want to quick talk about what Ansible is. Like, what is Ansible? So Ansible is a way to automate the deployment of servers in the cloud. All of the steps we took in the previous stream episodes, we used SSH to log into the server, and then we typed commands into a terminal to install things on the server, edit files on the server. So Ansible is a tool that you can automate all of that. In order to get Ansible running, what you need is what's called like a host node. So that's where Ansible is running, where you run Ansible from, and where Ansible is installed on. So for me, that is the desktop that's sitting right in front of me running Ubuntu. And then you need an Ansible host. So the host is the thing that Ansible is automating. That's our cloud server up on DigitalOcean. So I've got a repo up on GitHub that contains some of the Ansible playbooks that we're going to use. So what I'm going to do next is not log on, I'm going to use the git submodule command in order to add a submodule path to this repo. And that way all of the code from this submodule path will go along with this stream. So let's see if we can get that to work. We'll click here for New Terminal. And then I'll look at this command. So we'll type git submodule add, and then the submodule that we want to add is from github.com/username, which is my username, /repo name, which is Ansible JupyterHub DigitalOcean. And then we're going to give it a path to go into. We want it to go into Season 1, Episode 08, and then we'll put it as maybe Ansible. So now we've got this new Ansible directory, and that's got all the playbooks that we're going to run. So since we've added that, I'm also going to type a couple more commands. Type git submodule -- init. Oh, just init. So git submodule init. Then we'll type git submodule update -- init -- recursive. And it looks like everything is all up to date. So we've ensured that our server's been created, and we made sure that the domain name was linked to the server. So let's check what's my DNS.net and see if the DNS changeover happened yet. So I'm here at what's my DNS.net, and I'll type in our address, which is engr114.org. So it says it's being routed through. So I think this is going to our server. Let's go back to DigitalOcean. And this is .129. So it's going 129. So it hasn't quite propagated everywhere to that 129 IP address. So we can work on a couple more things before we get that far in our deployment. But we just wanted to make sure that that's already created, because that's the thing that takes the longest. So next, let's install Ansible, and I'm going to install this into a virtual environment. So you can create a virtual environment using either Conda or using Python's built-in VNV module, and there are a couple other ways too. So I'm going to cd into the Ansible directory, cd Ansible, no such. Oh, we got a cd into the stream 01, episode 08. Maybe make our font size a little bit bigger here. And now if we ls, yeah, we see Ansible. So we'll cd into Ansible. And in here, I've got a requirements.txt file. So I'm going to use the command python -m venv. That will call the venv module, and then we'll create a virtual environment called venv. And when we run this, a new virtual environment will be created. And if we type ls, now we should see a venv directory. I want to make sure that this directory doesn't get added to the GitHub repo for all of our stream stuff, because that would be a huge amount of things. So here, let's go to git ignore, and let's modify this that we don't want to include season 1, episode 8, the last episode in our season, venv, that entire directory. We'll give a save. And now this has been grayed out, and that's VS Code's way of saying this isn't part of the repo that'll get pulled up to GitHub. That will be ignored. Okay, now we need to activate the virtual environment, and on Ubuntu and Mac OS you can use the following command, which is source venv /bin/activate. Now that our virtual environment is active, we can see venv is in front of our prompt. And next, what we'll do is we'll install all of the packages that are here in this requirements.txt file, and that includes Ansible. So I'm going to open up this requirements.txt file, and we can see that Ansible 2.9.9 is one of the packages which will be installed. So we'll type the command pip, actually we'll do python -m pip install, and then we'll do -r for recursive requirements.txt. And this will grab all of these packages from PyPI and install them locally. So it says here we should run this command so we don't see this warning every time. I wish it did this automatically, but we'll run python -m and then pip install --upgrade pip to make that warning go away. Okay. Great. So now that Ansible is installed, if we type Ansible and then --version, we should be given our 2.99 version, like we saw in our requirements.txt file. So now Ansible is installed on our local machine. So let's go back to the contents for today. Once we've installed Ansible, now what we need to do is we need to copy a hosts file and copy a default.yaml file that contains our variables. So this hosts file, that will contain the IP address of our DigitalOcean server, and this default YAML, this file, that's going to contain all of the variables for our deployment. So let's do this here on the command line. If I type ls, oops, I didn't want to do that, ls, there's this hosts example file. So we'll copy this hosts example file with the cp command. So we'll copy cp hosts example, and we'll instead create this hosts file. And we'll also do that with the vars / default. So then, actually I need to go and let's do ls vars. So it's called default example. So we'll cp vars default underscore example dot YAML to vars slash default underscore just default dot YAML is what we need to do. Now if we do an ls in the vars directory, we can see we've got a default.yaml file. So I'm going to do a pwd here, and then we'll grab this directory, and we want to add these to git ignore. So Ansible / hosts and also Ansible / vars / default .yaml. So now if we look here, then this hosts has been grayed out, and if we go into vars, we can see that default that has been grayed out. Okay, so let's fill out hosts first. So this says that we need to put in our server's IP address. So we'll go back to the DigitalOcean dashboard, and we'll copy the server IP address. I'll stick that in there. Give that a save. Save the git ignore. And then let's open up this variable file, this default YAML file, and see what we need to fill in here. So I can see that, whoa. Just want to make this a little easier to see. Maybe like that. Does that make it so that you can see stuff a little bit better? Maybe we'll leave it like that. Okay. So we need a username, and this will be the username that goes on the server. I'll keep that as Peter. Then there are these Sys packages. These are the packages that will be installed on the server using apt or apt-get. And I think those are okay. Then there are the Conda packages. These are the Python packages that we want to install with Conda in our JupyterHub server. And requests, this needs a quote mark there. Then the Conda Forge packages like JupyterHub, Authenticator, and Pint. They're not part of the standard Anaconda channel, so we'll install those two. Then we need our domain name, so that was engr114.org. And then we'll need email address, the college name, the college domain, and then college username, and then who you want to allow to be the JupyterHub users and who you want to allow to be the admin users. So I'm going to fill this stuff in with just the little privacy screen up here. So we'll fill in the email, and this is the email that you'll use for Let's Encrypt. Then the college domain, That's the domain name that all of the users have to have. And then I'll say my fancy college for the college name. And then I'm going to put in the college username. And then JupyterHub users. I'll put in that. And then also the system user. And then for the admin users, I'll put in the first and the last. And give that a save. So I've just filled out here all of the stuff in this default example into the example file, but filled in the things for my particulars. And request, this should be in quotes here too. All right, great. So we've copied those files for Ansible to read. Next, let's take a look in our contents. What is our next step here? So next, we'll check the server connection with a ping. So we can just send a ping to the server to make sure that it's actually the server that we want to be sending all these commands to, and also make sure that we can connect and that our SSH key is valid. So I'm going to go here to this Ansible subdirectory, and then in the README, it's got the commands. So first, actually, let's do this Ansible-I hosts hostless all. So this is called an Ansible Ad Hoc Command, and it is used to run just an individual command using Ansible. What is going on here with my prompt? Maybe if we go one smaller. Okay, that's maybe a little bit better, although probably harder to see. How about if we do that PS trick? Let's see if this works. Haha! Alright. Cool. Okay, let's increase our font size again. Alright. So we'll go back here to Ansible and then to the README. Whoops, that's not the Ansible README. Here we go. There we go. Okay, so we'll do this Ansible-I hosts list hosts all. So what this command means is we're running Ansible as an ad hoc command. -I is for the inventory. That's the servers that we want to run the command on. And that inventory comes from the host file that we just modified. Then this --list hosts flag, this will print back the IP address of the servers that we're running this command. And then all means all of the hosts in the host file. We only have one host in our host file, so it's just going to give us one IP address back. So I'll copy that and paste. And we see the IP address of our DigitalOcean server. Nice. So next we'll ping the server using the Ansible Ping command, and hopefully what we get back is Pong, and that means the server received the command and it sent something back, and that our SSH key works. So we're typing Ansible to run an Ansible Ad Hoc Command, -I again for hosts. The hosts in our host file, the IP address of the server, and then -M, this stands for the module, and the module we're calling is the ping module, and we want to do it against all of those servers in the host file. So I'll copy that, and then down here we'll paste it and then run it. So it says, are you sure you want to continue connecting? Because this is the first time we've connected to the server. And we'll type yes. And hopefully what we get back is a Pong. Sweet. Okay, so this means that we are ready to run our first Ansible Playbook. So an Ansible Playbook is a YAML file that contains all of the commands that we're going to run on our server. So our first playbook is going to be this initial server setup.yaml playbook. So let's take a look at this initial server setup.yaml playbook here. Okay, so we'll go through this one in a little more detail than the other ones. So first of all, this is a YAML file, which is a file format, sort of like a JSON file or like a markdown file. And these YAML files all need to start with triple hyphen. Then here, this is saying which hosts we want to run this playbook against. In our case, all of the hosts that are in our host file. This become true means we want to use these commands as sudo, or we want to elevate as sudo. And then the vars files, those are the variables that we filled in the default.yaml file, like what do we want the user's name to be, or what do we want the IP, not the IP address, the domain name, all those variables that we filled in. Then below that is something for tasks. So in Ansible, the tasks are the things that we're making the servers do. And you can have a name for each task and then a module. So a module is sort of like a function. It's a reproducible sort of operation that you do on the server. And I sort of think of it like a function or like one command that you'd run on over SSH. So here we're using the apt module, the package manager for Ubuntu, and we are upgrading and updating everything on the server. This is equivalent to sudo apt update and sudo apt upgrade. This task is going to take a little bit of time to run the very first time. Then we've got this cache valid time for 1 day. That means if we rerun this playbook, it won't do the updating again, at least for a day. Then we're going to create a sudo group called wheel. Then we'll give wheel sudo privileges. Then we'll create a new user, and that new user is going to have the username variable from the variable file. And then we want to make sure they're present, that they belong to the wheel group so that they have sudo access. we want to give them a home directory, and then we want to define which shell that user should use. So this is using the user module, and it's kind of equivalent to like the create user command on the command line. Next, we're going to synchronize the SSH directories, because when we created the server, our keys are in root /.ssh, and we want them to go into our new users directory so we can log in as that new user. And then we're also setting the group and the owner to that user. And then the delegate to inventory host name, I think, just means that it's supposed to be done on the IP address, I think. Next, we'll disable root login. This is using the line-in file module. It's basically going to stick a line in this SSD config. I'll just make it so that you've got to use an SSH key to log into the server. Then we'll install a bunch of packages, the packages that are in this Sys Packages variable in our defaults.yaml file. Then we'll use the UFW firewall to allow SSH connections, and then we'll deny all of the other connections. Let's give that playbook a save. And next, what we'll do is we will run the playbook. So if I type ls here in my terminal, I can see this initial server setup.yaml. So we'll type Ansible -playbook and -I for inventory and hosts, and then we'll do initial. Let's see if it'll give me some tab complete. Sweet. Initial server setup .yaml. So this will run the Ansible Playbook. It's gathering facts. That means it's storing facts about the server. So now it's doing the sudo apt update and the sudo apt upgrade. This is probably the thing that will take the most amount of time. So I'm going to take a drink of water while this happens. The first time that you do a sudo apt update, sudo apt upgrade on a brand new server, that usually takes a little bit. So it's not unusual that this is taking a while. I would expect that this takes a little while. Is still going. On server upgrade. Be interesting to see if Linode servers update faster than the DigitalOcean servers. I don't remember when we were doing this in our previous deployment that it took so long. And hopefully the reason that it's hanging is that it just takes a little while to do the apt update and apt upgrade, and that there's not something wrong with our Ansible Playbook. Alright, good. That went. So created the wheel group, gave it sudo privileges, created the new user, moved over the SSH keys, disabled password authentication for root. So now it's installing the system packages. That was pretty quick. Allows SSH connections. and it's done. So now we should be able to log into our server with our new user. So since I'm on a Linux machine, I can just use SSH. I don't have to use PuTTY. I can do SSH and then our user's name, and then the IP address of the server, which is conveniently printed right there. And it worked. And if we do something like type sudo apt update and sudo apt upgrade, and maybe we'll do an EY flag here so it doesn't ask us if it's okay. This should go really, really fast because we've already updated the server. Nice, awesome. And then we can exit out and go back to our local machine. Now, a neat thing about Ansible is that Ansible is stateless, which means we can run the same playbook over and over, and it shouldn't make any changes if those the state of that machine has been created by the playbook previously. It's also called idempotence. So let's run the playbook again and see if anything gets changed. It's still doing the gathering facts part, but hopefully all of these say okay. So far, all of them have been okay, and they didn't ask for anything additional. Sweet. Alright, so that's equivalent to creating the non-sudo user, kind of like what we did in episode 2. Let's go back to this README. And next, we'll try our next Ansible playbook that installs Miniconda. So we'll look at this one a little bit quicker than the last one. So in this playbook, we're running it against all of the hosts and still using the same variable files. And first we're checking if a couple things exist, like the opt Miniconda 3 bin Conda. That means that Conda's installed. Also that this opt Miniconda 3 bin Python, that means Python was installed with Miniconda. Then check if the Miniconda installer was downloaded, and also check if the Miniconda installer or the Miniconda installation directory has already been created. The reason we're doing all that checking is that if we run the playbook again and those things have been created, then we don't need to do the steps that created them. So next we're using the getURL module to download the Miniconda installer .sh script, and we're saving it in here to tmp install miniconda.sh. And it says when not Miniconda installer path.stat.exists. So this means if the Miniconda installer path doesn't already exist, then download the installer. But if the installer is already there, we don't need to do the download. Next, we create a Miniconda 3 directory, and this is using Ansible's file module, and the state is directory. And we're setting the user to our username from the variable file. And then we do this when that install directory path doesn't exist. Next, we run the Miniconda installer, and there are a couple flags here, -b, -u, -p. This -p means for which path for installation, and we put it in that directory where we want it to go. And we want to run this when the Conda executable doesn't exist and when the Python executable doesn't exist. Both of those things exist, then that means Miniconda has already been installed, and so if you run the playbook again, it doesn't need to be run again. Next, we reset the permissions for read permission for all, and then change and allow execution. And then finally, we add the Conda binary executable to the system-wide path variable. And we just want to do that because then we can call Conda from the command line. Alright, so let's run this Ansible Playbook. So we'll type Ansible Playbook -I for inventory against the host, and this is Miniconda install.yaml. I'll click enter. So it's doing the gathering facts again. And now it's checking for the Conda executable. It doesn't exist yet. Checking for the Python executable. Doesn't exist yet. The Miniconda installer script, not there yet. The directory, not created yet. Just downloaded the sh installer script, created the directory. Now it's going to run the Miniconda installer. This step may take a little bit longer. Now it's adding read permissions and execution permissions, and then adding the Conda directory to the system-wide path. So if this has been completed successfully, if we SSH into the server, and then we type conda -- version, it tells us which conda version we're in. And if we type conda init, then it's made some changes to the shell, and so we'd want to do source /home /Peter /-bash rc. It reloads our bash rc file, and now we get this base in front of our prompt because we're using Conda. And if we type Python, that'll give us, now it's saying we're using the Anaconda version of Python. This is 3.7.6. Great. Okay, a couple more playbooks to finish out our installation here. So the next playbook that we're going to run is we're going to run the JupyterHub install playbook. Go over this one real quick. We run it on all of our hosts as a sudo user and all of those variables. We do a couple checks like whether the environment has been created yet, whether the Python executable in that Conda environment has been created yet, whether the SRV JupyterHub directory has been created yet, whether the proxy auth token or the cookie secret has been created yet, and then print us out if they exist. So first we're going to create the Conda environment, JupyterHub env. So that's what we're doing here with the shell module. We're running this long command. And we've got to put the full path to the Conda executable, and then this dash dash prefix gives the full path of the environment. Then we'll do this as sudo, and we'll only do it if the JupyterHub Conda environment doesn't exist already. Then we'll install a bunch of packages, and those are the packages that were in our variable file. Then we'll install JupyterHub and JupyterLab from Conda Forge. So that's why we've got this -c Conda Forge flag here, and we don't have that here. And this special item variable is an Ansible variable. And now you can do with items and then a variable from our default.yaml file, and it'll run this command one time for every item which is in this Conda packages variable. Then we'll make changes to the permissions. We'll create this etc JupyterHub directory. Then we'll template a file onto that directory, and the file that we're going to template over is this JupyterHub simple file. This is like one of the simplest JupyterHub configuration files that you can. Ansible uses Jinja templates, so we put in these variable names in double curly braces. And then we'll create a cookie secret and proxy auth token. Those are good for security that we'll use later. And then we'll create a systemd service file, and then reload the system daemon, but we don't actually start JupyterHub. So let's run this playbook. So at our terminal, we'll type Ansible-playbook-I for hosts, and then JupyterHub install.yaml. So it should do that gathering facts again. And then it'll do these checks, see if the JupyterHub env already created, if the Python executable in the JupyterHub env was created, the server directory exists, the proxy auth token or the cookie secret has existed, and then it creates the Conda environment. And now it's going to install those packages from the default Anaconda channel. And it's going to run that line that we put in the shell module one time for each one of these packages. Some of these packages are pretty big, and it may take a little bit of time for them to install. Like matplotlib in particular is a pretty big package. Pandas also pretty big, so is Jupyter. XLRD, that one should install pretty quickly though. I think SymPy is also pretty big. So once it installs all of those packages from the default Anaconda channel, now it's going to install the packages from the Conda Forge channel, because JupyterHub, JupyterLab, they're not on the default Anaconda channel. At least I don't think JupyterLab is on the default Anaconda channel. Also, Authenticator, we need that one. And then this package called Pint, it's used for unit conversions. I think it's really useful to have and be able to run in Jupyter notebooks, that unit conversion package, Pint. Oh, it didn't install JupyterLab. I would sort of like it to. So once all these go through, I'm going to change the defaults example to use JupyterLab, install from there too. So if we're here in VNV and vars, default example. Oh yeah, JupyterLab is not one of them. JupyterLab. So I'm going to change this in my vars, my default vars too. So I'll add JupyterLab here. Good. Okay. So since I added JupyterLab, if we rerun our Ansible Playbook, then it should redo the installation. I haven't quite figured out how to make the Conda package installation stateless so that it's idempotent. It always runs the installation. It's not going to do like the creating the cookie secret, proxy auth token, or templating over the file, but it still runs all of these with the shell module. I tried figuring out like where NumPy is in the Conda environment, but I couldn't quite figure it out. So once I do that, then maybe we can make this more idempotent. It's not actually reinstalling the packages, it's just running the command and then it's saying already installed. Also, maybe we could collect the output and sift through that output if it says requirement already satisfied. So here, let's see if it adds JupyterLab after JupyterHub. If there was a problem with a syntax error in that file, then it might not work. Yeah, there, JupyterLab, since we added that right up here. And after it installs Pint, it should go pretty quick because all of those tasks were run before. Great. Okay, let's log into the server, see if we can run JupyterHub, see what happens. Okay, so I'll copy the IP address, and then we'll SSH into the server. And since we already did the conda init and the source.bashrc, we don't have to do that again. So let's see if we can run conda activate JupyterHub env. So the virtual environment was created. Then we'll cd into the etc/JupyterHub directory. And then if we type JupyterHub --help, so we got a whole lot of things that we can do. Command args, JupyterHub command.h. So I don't want to generate a config file, and we'll try the --no SSL. Maybe -c is for config? I don't know. Let's see. JupyterHub. Oh, it's -f. So -f etc /JupyterHub /JupyterHub _config.py and --no -ssl. Let's see if that runs. Looks like it worked. Okay. So let's go over to a web browser and copy our IP address. I think it runs on port 8000. Is that right? 801. Maybe port 8080 if that doesn't go. If that doesn't go, let's try 8080. Doesn't go. Okay, well, let's see if our system service works. Let's do Control-C and sudo systemctl start JupyterHub. Now sudo systemctl status JupyterHub. Says active and loading. Let's try it one more time. Going to the IP address of the server. Port 8000. Oops, not 800. Alright, well, for right now, I'm not going to worry about that. Do Control-C to cancel, and then we'll type sudo systemctl stop JupyterHub, and then we'll exit out of the server. So next, we will install Nginx and configure it using Ansible. So in this Nginx installs playbook, we're still going to our JupyterHub server and using our variable file. And then we're checking to see if these security files already exist from Let's Encrypt, our full chain and priv key from Let's Encrypt. And this will only work if the DNS changeover works. Then we'll check the SSL certs if they're in there, and then we'll do an apt-get upgrade. This probably won't run because it hasn't been a day. Then we'll create the dhparam.pem file. This takes a little bit of time, and we only want to do that if this file isn't already created. Then we want to change some permissions, and then we'll look if it exists, and then if it doesn't, we'll say it doesn't exist. It's probably something I can take out of the playbook. I just wanted not to create it again if it's already been created. Then we'll install Nginx. We'll move over our Nginx config file from the templates directory, and then we'll also move over the sites available file from the templates directory, and then we'll create the symlink to link the sites available to sites enabled, and only do that if the SSH keys already exist. Then we'll make systemd reload, and then we'll make it start the system daemon for both JupyterHub and for Nginx. Then we'll allow Nginx full in through the UFW firewall. And then hopefully after that, we should be able to log in using our domain name. Let's see if it works. This all depends on whether the DNS record has propagated all the way through or not. So we'll type Ansible Playbook -i hosts, and then Nginx install.yaml. So it's doing the gather facts again, checking for that full chain.pem key shouldn't exist yet, that priv key.pem key. So it says SL certs are missing, haven't been created yet. So now it's creating the dhparam.pem file, and our note to ourselves was it takes a minute or two, so be patient. Depends on how many probably CPUs, how fast those CPUs on our server is, how quick this goes. I think it took like maybe a minute when we did our manual deployment on Linode. So then changing the permissions, and now it says skipped because the file is present. Now installing Nginx. This might take a little bit of time. Alright, so I'm going to try running this playbook one more time. Oh, I realize what's happening. So the reason that it skipped those was that our privkey.pem and our certs are missing. So we should have actually run a different playbook, the SSL playbook first. So this won't take too long. But it does the Nginx install, but it doesn't move any of the files for the Nginx configuration because the SSL certs haven't been created yet. So we need to run that playbook next. Alright, so this SSL playbook looks to see whether the SSL certs have been created yet. It updates the cache, then it installs certbot, and then Python 3 certbot Nginx, the Nginx kind of like extension to certbot. And then it opens up port 80 so that certbot can do its work. Then it runs certbot, and then if you run certbot just from the command line and you don't type anything in, then the -d flag is the domain name, --nginx, because we're using nginx as our reverse proxy, and then this -agree tos, that means that you don't have to like manually type in yes, and then -m is for email. And then we want to print out what certbot tells us, and you don't want to do this if the keys already exist. And then we'll print out whatever certbot says, and then we'll close up the port. So if this works, that means the DNS changeover is complete. So we'll type Ansible Playbook-I for hosts, and then SSL-YAML. Whoops. Try that one more time. Okay. Let's make this terminal window nice and big here. So it gathers the facts and then sees if the PIM, so this one, those shouldn't exist. Certbot shouldn't have been downloaded yet. So now it's installing certbot. This may take like a second or two. I don't think certbot's like a huge package. Now it's installing this Python 3 certbot Nginx package. Then opens port 80 on the firewall. And then this is the step that might take a little bit of time and might not work. We'll see if our DNS record propagated all the way through or not. Alright, so let's see. So it said challenge failed for enjr114.org. So maybe the domain name hasn't propagated through yet. Let's try to run it one more time. So the install certbot, that should go quicker. Install Python 3 certbot Nginx, that should go quicker. And let's see if we run this again, if our DNS changeover is complete. So still not yet. Okay, let's go to what's my DNS and run this. So it looks like there are like multiple servers that this is currently being routed to. And that's probably why this doesn't work yet. So if it doesn't work this time, that maybe just because the DNS isn't through yet. Yeah, it still hasn't worked yet. So that just means we need to wait time in order for the DNS record to propagate. So I think what I'll do for today is leave the stream here, because until that DNS record propagates, we can't get our SSL certs, and then doing the rest of the install steps aren't gonna make a difference. So I think I'm gonna close that. And then let's see about doing git add dot here, git commit dash m after stream dash 2020 season 01 episode 08, then git push origin master, and then we'll say allow continue, authorize GitHub. So I'll type in my password here, but I'm going to put the privacy up. This link needs to be open with an application. Send to open link. Open. Wow. Okay. So it looks like it pushed those changes up. And now we'll cd into the stream 2020 directory. Do git add dot git commit dash m and season 01 episode 08 and git push origin master. And now I'm going to go to GitHub and just make sure that things that should not have been brought over were indeed not brought over. So in the stream 2020, if we go here, okay, don't see anything there. Now if we click this, that goes here. So we've got host example, but no host, so it didn't save that. And then vars, got default example, and it saved our change for requests, but those aren't secrets. Sweet. That is great. All right. So thank you for joining me today. I wish that the DNS record had fully propagated so we could finish up our deployment, but that is not the case quite yet. So if you've been following along, next what you would do would be run the, excuse me, let's go here, here. Next, what you would do is you would run the ssl.yaml playbook and then the Nginx install playbook. Then you'd add a couple of credentials to a JSON file called clientsecret.json in the vars directory, and then run the googleoauth.yaml playbook. And that will basically do all of the JupyterHub installation steps in just a couple of command line commands that it took us 7 weeks basically to complete, which is pretty amazing. So thanks for tuning in to the stream this week. I'm going to take a little break from streaming for a while, and after this I'll be coding another project on stream. So thanks a lot.